Let's take a look at an example. Let's let B be a basis for the set of all polynomials of degree 2 or less. We're going to let T be the transformation of the coordinate vector of any polynomial P with basis B. It gives the coordinate vector. So we want to find the transformation of 2x squared minus 11x plus 1. Notice that means we want the transformation of 2x squared minus 11x plus 1. That means we want the coordinate vector of 2x squared minus 11x plus 1. Okay? So that means I want to find the coefficients that would allow me to express this input vector as a linear combination of the vectors in the basis. Okay, so this is going to be equal to A1, A2, A3, where A1 and A2 and A3 are the coefficients of the following linear transformation. So let's do A1 times the first vector in the basis plus A2 times the second vector in the basis plus A3 times the final vector in the basis. Okay, so now that we know what we're looking for, how do we find it? Well, we've already done this in a previous section. We just need to figure out what A1, A2, A3 is. So if we distribute, if we combine like terms, we will get, let me focus on x squared first. I get what? A2x squared plus A3x squared. So I get A2 plus A3x squared. Now let's think about the x terms. I get negative 5A1x, and then negative 3A2x. And then I don't get an x term here, so that's going to be negative 5A1 minus 3A2x. And then let's worry about constant coefficients. I get negative 3A1 plus 2A2 minus 5A3. Negative 3A1 plus 2A2 minus 5A3. So in order for these two polynomials to be equal, the coefficients of the same terms must be equal. So that must mean that the coefficient of x2 on the right side, a2 plus a3, must equal to the coefficient of x squared on the left side, which is 2. Okay? The coefficient of x on the right side, negative 5a1, minus 3a2, must equal to the coefficient of x on the left side, which is negative 11. And the constant term on the right side, negative 3a1 plus 2a2 minus 5a3, must equal to the constant term on the left side, which is 1. This gives us a system of linear equations. We can solve this system and find a1, a2, a3 using the augmented matrix 0, 1, 1, 2. That's the first equation. Second equation, I get negative 5, negative 3, 0, negative 11. And last equation, negative 3, 2, negative 5, 1. So let's get this matrix into reduced row echelon form, and then we can from there figure out the solution to this the system of equations and my coefficients a1, a2, a3. So row 1 is 0, 1, 1, 2. Row 2 is negative 5, negative 3, 0, negative 11. Row 3, negative 3, 2, negative 5, 1. Find the reduced row echelon form of the matrix. And there we go. reduced echelon form is 1, 0, 0, 1, 0, 1, 0, 2, 0, 0, 1, 0. Okay, so this first column corresponds to variable A1, the second column corresponds with variable A2, the third column corresponds with variable A3, and the last column is my augmented part. So the first row, I'm going to get 1A1 equals 1. The second row, I get 1A2 equals 2. And the final row, I get 1A3 equals 0. And so that gives me A1, A2, A3, which gives me the answer to the transformation. So the transformation of 2x squared minus 11x plus 1 is 1, 2, 0, the coordinate vector of the polynomial with respect to basis b.